People's got a long break, I think 12:45 to now. Excellent. Up to now? No, no. So break there, 4 to 5:15. Computers class, okay. So you people, have you received that paper? Yesterday paper. Not received. Have you received the paper or not? Remaining. What about remaining? Subhadeep not received. Then so now I tell them, then they will send the paper. If you are interested, see today after the study hour, and we discuss some important questions from the yesterday paper on tomorrow class. Okay. Otherwise, why we go now? I think better, maybe. I think it's better we go today. See, Nana, other than the discussed topics, means some easy questions are given to you. Pulley questions, normal reaction, and tension in the string, block on block. Other than them, the few questions we discuss on board now. You see the question number 2, first one. See here, I think you did this question maybe. The work done by normal reaction. See here, this is the N value. This is the downward mg. Work done by normal reaction means N into displacement covered S. N means M into G plus A, normal reaction because it moves up into S. Okay. Now you see, in the time t seconds, S is equal to ut plus half at square, 0 plus half into a into t square. So at square by 2. Therefore, W equal to m into g plus a value how much nana? G by 2 into half into g by 2 into t square. You'll get 3 m g square p square upon 2 to the 4 to the 8. Not down. Few questions I give you now. All you note down. Other than the discussed models. Have you got my point? Other than the discussed models. Of course, this is easy. Straight question, normal reaction. I think you have got two questions straightly. Same questions maybe. That 12 and 13. 12 and 13, two questions. Yes, from material, all from material only. All from material. That question I give you now. That model. Remember 12 and 13, same questions. All surfaces will be smooth. All surfaces are smooth. Then acceleration of rod A1, acceleration of prism A2 question mark. Both cases given A1, A2 with different options. Anybody have tried? It's a straight question. This is also discussed model, but only the direction of the forces. Now you seen and all, just listen. Is it possible to move with some acceleration here? These are possible or not? Yes, because you see, when it tends to move down, the prism tends to move right. Means suppose it can be moves down with acceleration a1, it moves up with acceleration what? A2. Means this rod should move downward due to its gravity mg, but this prism is moved rightward due to what? Some force acting on it by some force acting on it by who applies the force on the prism? Rod only. Okay. For that you see I give you the points. For example, you come back to know this is you see this is our Lakshmana. Here is a normal reaction. First one N1. Here is N2. This weight is M2. You should not work here. These are balanced. And this is N1. Immediately pseudo force also acting on it. F pseudo. N1. See the points I can take separately. Free body diagram. I give you the point P. See none of this. This is the P point. N1. Angle you see here. This angle given theta. Theta means Here theta, this is 90 minus theta, this is theta. So we can write n1 cos theta, this is n1 sin theta. So now you tell me what type of pseudo force should pushes the prism rightward? What type of force should pushes the prism rightward? N1 sin theta or N1 cos theta? N1 sin theta only, so I can give like this. This is this one, the point. What is this? N1 sin theta acts like a pseudo, also be called external force on prism. So therefore, N1 sin theta equal to M2 into A2. This is the equation number 1. Now another one you will see. For this one you come. For this one. So multiple forces again on rod. This is for the prism. For rod you can take. For rod, what are the forces upward? N1 cos theta. Downward is how much? M1 into G is moving down with acceleration A1. So M1G minus N1 cos theta equal to M1 A1. Equation number 2. And one more you see. Acceleration directed downward. This is the A1. This is A2. And now you can see here the points. Or you just see the points, components. Which component should not be what here? So this is theta. So we can take the components again. This is theta, here also be a theta. A1 cos theta, A1 sin theta. Now you can extend. This is theta. This is how much? A2 cos theta and A2 sin theta. So you see in which direction system is in equilibrium. The relative acceleration along this direction should be equal to how much? The relative acceleration between these two should be equal to how much? 0. So from the figure what I write? A1 sin theta equal to A2 cos theta. So we want to calculate the A1 and A2. So first I can write A2 equal to A1 tan theta. Equation number 3. Put all the things. What we do, you see? What we do now? From 1, N1 sin theta equal to M2 into A1 tan theta. So we want N1 equal to M2 A1 into sin theta cancel, remaining how much? Cos theta. So now from 2 M1G minus N1 means M2 A1 cos theta upon cos theta equal to M1 A1. I think we have done mistake. Any mistake we have done? I think components we have done mistake. Any mistake? Check now. Horizontal bar of mass M. Components we have done mistake. Here only we have done mistake. The point P, downward acceleration A1. Era any mistake ra? Just check components. Components you need to check now. Same only. Right. Directions we have taken reverse. Directions we have taken reverse. See that. Relatively you consider the angles. See angle and accelerations. See along this direction it should not move. This component should not work in the system. A2 sin theta, A1 cos theta. Previous case I have taken reverse downward. That's why we are not getting. Say this. Now you put in the values from 1. N1 sin theta equal to M2 into A1 cot theta. So N1 equal to M2 A1 cot theta by sin theta. Now from 2. M1G minus N1 means M2 A1 into cot theta into cos by sin again cot theta equal to M1 A1. So M1G equal to A1 into M1 plus M2 cot square theta. Now what is A1? M1G by M1 plus M2 cot square theta. I can take like this. G by 1 plus M2 by M1 cot square theta. Also be written G by 1 plus theta of cot square theta. This question given in terms of eta here. Eta equal to M2 by M1. M2 by M1. This will also be written like this. What we write? G tan square theta upon tan square theta plus theta. If you know A1, then A2 equal to A1 into cot theta. A1 into cot theta means G tan square theta into cot theta. So G tan theta upon tan square theta plus theta 1. Theta. So multiple options. Only the components pseudo. We should take care about the direction because when A1 tends to pull down, then the force should act in the upward direction. Only the components. Directions, okay, free body diagram, both in the case of acceleration as well as forces. Then only you get the correct answer. Twelve or 13. If you solve one question, 1 into 2 bonus. Last one more question. Based on the impulse given, one question. Actually, we will do the collision part of tomorrow, but you have got one question strictly based on fundamentals. Last, after that, if you have got any other questions, doubt, ask me. Then I explain on board. I have written the last question. This is the question number 14. And numericals given almost straight questions, all are based on the momentum. Two questions based on the momentum. Okay. Written where? I written this. Now you see, anybody solve this question? Anyone? Or 2, 3, 4, all? Any one of you solve this question? They ask you to find kinetic energy of translation of the rod. Translational kinetic energy of rod. I square by 2m. rotation of rod I square by 6m. Rotation of rod 3l square by 2m. Kinetic energy of rod is 2I square by m. I square none of this. See this question. You just share with me the point now. Suppose we are suspending like this only that any uniform rod. If you fire any bullet towards the what rod, suppose if the bullet touches the center, is it possible to rotate? Bullet touches the center exactly. No. If it touches above or below the center at any point, definitely it applies some force on it, which is at a distance, some distance from the center. Hence, that force develops the torque and causes the rotation. At the same time, the rod tends to move forward also. So, here two possible cases. What are they here? In this case, kinetic energy of rod equal to kinetic energy of translational plus kinetic energy of rotational. Kinetic energy of translational is mv square. Kinetic energy of rotation is half I into omega square. So for this case, we need to calculate the velocity as well as omega. So I value how much here? Ml square by 3 or 12, because about center only is moving. Okay, Nana? And now apply the conditions one by one. See here. Force on the rod due to impulse. You know, from the according to Newton's second law of motion. According to the Newton's second law of motion, F is equal to change in momentum by time. So momentum nothing but a what? Impulse. I can write directly K translational is equal to how much? P square by 2m. So directly they have applied I square by 2m. So here is a I of rod I give you. This is I means impulse. So check the option there. I square by 2m directly there. Relation. This one got another translational. We got this. Option A is correct. If you want, we can derive F equal delta P by delta T. Again we replace. Same thing only. Relation between kinetic energy and momentum. Got right? This one, we know that relation directly. But number 2 you see. Torque due to, the collision here, collision only applied. Collision means what type of law can be applicable in this case, otherwise directly I can apply law of conservation of what is this? Angular momentum. L is equal to momentum into R perpendicular equal to I of rod into omega. See, P means nothing but an impulse. I into what is the perpendicular distance about center? L by 2. L by 2 equal to I of rod how much? ML square by 12 into omega. So 1 L get cancelled. Then what I write? 2 6 times omega equal to 6 of I by M into L. Why is that this one omega? Because we calculate the value of rotational kinetic energy. And now tell me what is the rotational kinetic energy? Rotational kinetic energy equal to half I of rod into omega square. So KR equal to half I rho damage ml square by 12 again into omega square 36 into I square by m square L square. L square get cancel. 1 m cancel. 12 3 times. So 3 I square by 2m. There KR 3I square by 2m is there. AB there. And the total kinetic energy is equal to how much? KET plus KER. KET how much here? I square by 2m plus 3I square by 2m. Both the denominator 2m only. Now, how much that? 4I square by 2m will get 2I square by m. So option should be A, C, D. Three options you have got. Check the key all. A, C, D. 2 points. Why conservation of angular momentum? Because we are giving impulse. Impulse means nothing but a change in momentum by using some external bullet or rod or you apply force. Means the Newton's law applicable between these two. That is internal forces. There is no external force. So that due to the internal torque, the momentum of the system remains constant in the linear motion, but in angular motion, angular momentum constant. Next class, this one only we will do more. One bullet this side, one bullet this side. How it can be rotates, how we use this conservation of momentum, one by one we will discuss. Standard model. Note down. Okay, Rana, return. Actually, 12th part left. That current electricity, you peoples concentrate on all electric current, current density, drift velocity, Ohm's law, ohmic, non-ohmic devices, model graphs, up to color code, all you revise from our copy, otherwise from NCERT textbook or material. Okay, up to color code. Tomorrow evening I explain that Kirchhoff's laws if you want. Any other doubts? Everything fine, Ra? Everything fine? Going on well? practice. The disc question one is there. That is we discuss along with our numericals on board. Morning I gave you one question. Rotating disc touches the floor, then how it accelerates and torque. Like that, you try that same question, number 5 from our paper. I tell them, they will send you the paper. After that, you try. Any doubts, you ask me again. We'll discuss. Any other doubts? Ask me all. Arpita, Dio, are you there? Reading the Arpita, Dio, reading. Here how you don't receive any message from your side. But anyway, doing or not? Yes. Arup Prushti, Avis Katak. Jyoti Prakash, not good. You don't go outside. Shubhadev, Pavis, Bangladesh and West Bengal both. Asit Datta, okay. Decreasing nowadays. Will decrease. The strength of corona, how much time it maintains same ability yet? Strength will be reduced gradually. Suppose initially we start advanced classes, people are excited more. Gradually what happens? Decreases. Again will rise. So, but not corona like that. It's rising already, it falls completely. The coming days. It falls completely, but up to everybody, we should take care ourselves. Thank you, Nana. Take care all. Bye-bye. How many more years? No. Everybody will come outside only. We don't care the corona. When we don't care, everything is normal. But it does not happen like that. Maybe 2 more months. Bye-bye.